Hello everyone. So today our topic is phases of a compiler in unit 1. Just like I've discussed the important questions in the previous video, all those question and answers I'll give it to you here clearly. Okay. So in phases of a compiler, we basically have two parts of compilation phases. Okay. So the first one is analysis and second one is synthesis. Okay. So analysis is nothing but analysis part is also called as front end. It breaks the source program into constituent pieces and has a grammatical structure on them. So what happens in analysis part is basically called as front end. So you have to remember this. Analysis part is called as front end and synthesis part is called as back end. Okay, so these 2 points you can remember. Analysis is front end, synthesis is back end. Okay, next, what does analysis do? It breaks the source program. So whatever source program you have, it breaks them into constituent pieces and has a grammatical structure on them. So it gives a grammatical structure, like all the alphabets kind of things, everything comes in this grammatical structure. What is synthesis? Now synthesis part construct desired program from the intermediate representation. So what does this synthesis part does? It constructs desired target programs for the from the intermediate representation. I hope it is clear. Okay, now let's look at this diagram. You have to put this diagram in your paper. Okay, so this is the source code from where it is coming and this is the symbol table, this is the error handler. Okay, I hope it is clear. Now in source code we have lexical analysis, syntax analyzer, semantic analyzer, intermediate code generator, machine independent code optimizer, code generator, machine dependent code optimizer, and this is the target code. So after all this, it gets converted into the binary code, and then we then the program gives an input. Okay, after all these things happen, right? Next, let's see what is lexical analyzer now. Lexical analysis. So this is basically the first phase of scanner, works as a test scanner. So this is the first phase of scanner which works as a text scanner. Okay, I hope it is clear. Next one is this phase scans the source code as a stream of characters and converts it into meaningful lexmer. Okay, what is this? This phase scans. So in this lexical analysis, it scans the source code, okay, as a stream of characters. So what does it scan? It scans characters and then it converts them into meaningful lexemes. Now lexical analyzer represents these lexemes in the form of tokens. So lexical analyzer, it represents these lexemes in the form of what? Tokens, as token underscore name, attribute and value. Okay, I hope this is clear. Now next one is syntax analysis. Syntax analysis is nothing but the next phase is called the syntax phase or parsing. So what is syntax analysis is also called as parsing. Okay, now what happens in this? It takes the token. So in lexical analysis a token is prepared, right? So in this it takes the token produced by lexical analysis as input. So it takes that as input and generates a parse tree. So it generates a parse tree. Okay, now in this way token arrangements are checked against the source code grammar. So what happens in this syntax analysis? In this phase tokens arrangements are checked. So tokens are checked against the source code grammar. Okay, next comes our semantic analysis. Semantic analysis are nothing but semantic analysis check whether the parse tree constructed follows the rules of language. So it checks whether they are following the rules or not. Okay, the source code is following the rules or not. Now they keep track of identifiers, their types and expressions. So what exactly does this semantic analysis do? They keep track of these identifiers, types and expressions. Okay, next point is the semantic analyzer produces an annotated syntax tree as an output. So what does this semantic analyzer do? It produces as an annotated syntax tree as an output. So in the output it gives a annotated syntax tree. Okay. Now next comes intermediate code generation. What is intermediate code generation? Basically is after semantic analysis the compiler generates an intermediate code of the source code for target machine. Okay, so it generates an intermediate code of the source code for target machine. Okay, next is it represents a program. So what does this do? It represents a program for some abstract machine. It also represents a program for some abstract machine. Okay, it is between high level language and machine language. So intermediate code generation is done between high high level language and machine language. Next is code optimization. Now code optimization is nothing but the next phase does code optimization of the intermediate code. After the intermediate code generation, next comes or code optimization. Okay, now here optimization can be assumed as something that removes unnecessary code lines and arranges the sequence of statements in order to speed up the program execution. So what happens in this code optimization is basically they remove all the unnecessary code lines, like which is not in use. Even if that code line is not there, the program gets generated. So they remove such code lines and then they arrange them in the sequence of statements in order to speed up the program. They do code optimization. Okay, the next one is code generation. So code generation is nothing but in this phase the code generator takes the optimized representation of the intermediate code and maps it to the target machine language. So what happens here is they take this code generator into the optimized representation of the intermediate code and it maps to the target machine language. Okay, now here in code generator it translates the intermediate code into a sequence of relocatable machine code. What does it do in code generation? It does nothing but it translates the intermediate code into a sequence of relocatable machine code. Okay, next comes our symbol table. Now symbol table is nothing but it is a data structure maintained throughout all the phases of a compiler. So it is a data structure. What you have to remember, symbol table is it is a data structure which is maintained throughout all the phases of a compiler. Okay, now all the identifiers name along with their types are stored here. So what are stored here? Identifiers names and their types are stored here. Okay, next comes the symbol table makes it easier for the compiler to quickly search the identifier record and retrieve it. So what happens here? The symbol table makes it easier. So this symbol table basically makes it easier for the compiler to quickly search the identifier record and retrieve it. I hope it is clear. Okay, this was the last phase of a compiler. So there are basically how many phases of compiler? How many did you see? 7, right? So we saw 7 generators and analyzers. So I hope it is clear. Thank you so much.